Now that we've pretty much completed our schematic, let's look at what we're going to have to do to get these parts moved on to our printed circuit board. How do we do that? Because we have a blank circuit board. Here's my blank circuit board, and here's my op-amp schematic. You can see the tabs here of different projects that are open. I can always right click and close some of these tabs that we're not using. We're not using those old schematics there. Here's the license management. I don't need to look at that right now, so I just have my PCB dock and my schematic. How do I update my schematic to my PCB? Alright, let's take a look. Up here there's a tool called Design, and you'll see under Design it says Update PCB Document, and it has the name of the document, the PCB document that we created. So if I click Update that document, you'll see my engineering change order come in, and it's going to tell me enable, action, add components. I'm adding all these components, add the nets and classes, and then it has a thing here called a room. It's going to add the room. I'm going to let it add the room, and we'll talk for a second about what the room is, and then we're going to delete it because we don't need it for this design. So you can validate, and it'll tell me if they're all good. This one gave me all green checks. It thinks they're all good. I will tell you that sometimes you'll validate and you'll get a red X, and then you'll be wondering, what do I do to fix it? And I'll go and look at the part that's generated the red X, and what is it? I can tell you that 90% of the time, if you just tell it execute, you'll see they all turned green. Usually the red X's turn green too. If they don't, it's generally because it can't find a footprint. Maybe you've specified something and don't have the footprint library open. But anyways, we generated this. It's moved all the parts over. I'll tell it close. Now I can always left click. This works on the schematic as well as the PCB. If I push my left mouse button down, my pointer turns to a hand, and I can drag my screen around. So here's my parts that I've just imported, and this is the room, this kind of magenta colored thing here. And you'll see if I grab that room, I can move all the parts at once, and all the parts are inside the room. The room is generated because all these parts were on a single sheet in the schematic. If I had two sheets in the schematic, I'd get two rooms. Maybe this would be a good time to show that. So let me just save this. I'm going to go back to my schematic. I'm going to take this section and highlight it, and I'm going to do a Control X to cut it. I'm going to come to my projects. Here's my PCB guy. I'm going to come here and say add new to project, a new schematic. I'm going to tell it to save as. I'm going to name it something different. I'm going to call it OPAMP POWER, op-amp power. I'm going to then paste the stuff that I cut right here. You'll see they're not numbered. So I need to come to my tools. Let's see, tools, annotation, quietly, update those guys. Save. I can always do a save all. Now I have two sheets. There's my op amp and there's the power. Two sheets in one project. I could have 10 sheets in one project. They're all going to the same printed circuit board. So now when I tell it update PCB document, I want to create the component links. Very good. Execute and close it. And if you'll notice, I have this room here. Let me get it up here. And these parts belong in that room. You see they're green? Green is Altium's way of telling me there's a problem. It's not happy with something. So now look, I made the room a little bigger. I put the parts in the room. So you'll see that these parts belong to this room and these parts belong to that room. If I deleted everything, so I had no parts, and I came back up here and I said update, send everything to the PCB, close. Now you say I have two rooms. This room is my op amp. This room is my power supply. That's not going to do us much good in this design. It's not very functional for us here. Where it can be very functional is on a design that has multiple channels. Let's just say a sound mixer. If you've ever been to a concert and you see the guy sitting at the sound mixer board and he's controlling all those channels, right? There's a channel for the guy singing and a channel for his guitar, a channel for the bass, channel for the keyboard, maybe the keyboard's vocal. You see all these channels, and that circuitry is repeated over and over and over. So there's a gain control, maybe there's 3 tone controls, there's controls that say sweep it to the left or to the right, and then there's a master adjuster on there. When you do a design in Altium, you have the option to design that single channel and tell Altium to repeat it 16 times, 24 times, however many times you want it to. And when it does, and you move the parts to a PCB, it'll put each channel in a room. Now the advantage there is I can then come to the room and move these parts around inside the room and then tell it make all the other rooms look like this room, and it'll line them all up for me. That's where you have an advantage with rooms. Sometimes you can use it for a rule. I can set a certain rule inside of a room, but we're not doing that here. So I'm going to highlight the room and tell it I don't need it. And then I'm going to go back. If I go back to my designs over here, if I go to Project and Project Options, you see where I'm at, Project and Project Options, I have a tab that says Class Generation. I can tell it, don't generate the rooms because I don't need them. Thank you and OK. So now if I make a change and I update to my PCB, it won't add the rooms and I won't have to worry about them. So here's my PCB, right? This is my default size of the board. Here's my default parts. And if you notice down on the bottom corner over here, it has X and Y. It's telling me on the X and Y where my pointer is. So the edge of this board is basically 1 inch by 1 inch. I'm not starting at 0. I'm starting at 1 inch by 1 inch. We're going to change that, and I'll show you how to do that. But first, let's move our parts around. Here's my B and C connector. This is my power connector. Here's my 2-pin input connector. So maybe I want my 2-pin connector here. Look at the footprint on that op amp. That's not good. We're going to want to change that. This little R3, that was our output 50 ohm resistor where I picked a different resistor for the third one. Look at the footprint. Totally different. Let's see. Here's our input resistors and feedback resistors. Let's see. Now notice when I put this resistor here, you see that this line has to cross this line. Those are the net lines. It's going to be easier to route the copper if I just rotate that so they don't have to cross. Same as if I did this and I had this guy sitting over here somewhere and look, the lines have to cross. I don't want to make it hard, so I'll just rotate the part. That's your job as the engineer when you set this up, to make it easy to route. Now see where it turned green? I had that resistor too close. If it's too close, green tells me there's a problem. Now on my power connector, here's the horizontal connector. Remember this one was vertical, the pins come straight up. When I picked the 3-pin connector, I picked the 3H, H for horizontal. Those pins come up and bend over, so they take more space. Let's rotate him around. We can always go back to our schematic. I can look at the schematic, zoom in. I know that capacitors 1, 2, 3, and 4 are the ones that go on my power connector. So I'll come up here. Here's my power connector. And here's my caps. Now look at that. Those are crossing. So I can put this here. Here's where some of the art gets involved in how we do our layout. Look at how huge these caps are. Obviously, I could pick a nicer footprint for this. So I'm going to move these down. I'll move this guy here. Well, that connects pretty well. These caps are huge. We don't need them that big. Now I have these other two caps, C5 and C6. Those were the bypass caps that I had from my op amp. I could take that and look, they'll route right here just fine, but it's too far away from my op amp. I specifically placed those so I would be close to the op amp so I could have my bypass close to the op amp. So I'm going to put these close. Now here's that little 50 ohm resistor. Notice that he doesn't have a hole. The rest of these guys have holes. What's going on there? Well, these parts have a pad, that's a little copper pad, and a hole. Then a part goes through the hole. This guy doesn't have a hole. He just has a pad. That's a surface mount part. That little part is going to sit on top of the PCB. Let me show you a quick function. If I press the number 3 on my keyboard when I'm in the PCB, look what happens. I can see that little part in 3 dimensions sitting on top of the board. That's what it's going to look like. I'm moving the board around so you can see it. I'm holding down the shift key and my right mouse key, and I can drag this guy around. See that little part sitting on top? If I look on the bottom, no holes. Look at the rest of the parts, they have holes. So they go all the way through. When I'm done with this view, I press the 2, I go back to 2D view. If I press 1, it's kind of a manufacturing view. We don't use that much. I stick with 2. Just so you understand what this part is. Alright, oh, a little close there. He's still unhappy. I'll move him away. Okay, so here's my board. Obviously, I have this big volume of space here and only a few parts on it. I'm going to highlight all these parts at once and drag them down here. That's pretty good. Now, let me see. I might want to shuffle the parts around a little bit more. I'll move this closer. I'm going to move that designator. I can move this guy down. I can move him down. Okay, now obviously I have too much real estate. That board is too big for the amount of parts I have. So let's put a box around this, and we're going to do that. And when we do that, we're going to designate that as the shape of our board. Now, the layer we want is called the keep out layer. See on the bottom, I have all these tabs. Bottom layer, right, top layer here, top overlay, that's the text that you see on top. The keep out layer is what we're going to use to designate our board outline. So I'm going to come to my top up here and say place keep out track. Alright, now this is highlighted and I had already selected that. So I'm going to come here and zoom in, start my trace. Now notice when I'm drawing this box, if I look down here on the bottom left, I can see that I'm 1 inch by 2.7 inches. Now my offset was already an inch. So I'm basically 0 by 1.7. I'm going to click here. I know that says 2.7, so I'm going to come across and say, well, how big does my board need to be? Well, I need to come maybe to about here. So my X dimension, let's just say X could be 3,300 or so. That's pretty good. Am I going to be past this? 34, maybe 35. So I'll zoom in so I can keep my line straight. There's 3,500 by 2.7. I'm just drawing a box. I'm going to go right back down to this bottom. That's good. And I'll come right over to here. And I'll left click because I'm done placing. And if I look now, I've drawn a box around these parts. Now, how do I designate this to be my board shape? Well, first, I'm going to highlight one of those bars. Now, if I hold the shift key down, I can highlight them all, one at a time, or I can hit the tab key once and it highlights everything that's connected there. It's a little faster. After I've done that, I'm going to my Design tab, Board Shape, Define from selected objects. Well, I just selected my outline. That's going to be my board outline. Click on it. Now look, my board shape is inside my keep out. What do I have left to do? Well, I want to put my 0, 0 line down here. So I'm going to open up my toolbar here, utility tools, and you see this little guy, it says set origin, kind of looks like an atom with some electrons emanating out of it. I'm going to say set origin, and I'm going to come in here and zoom in right on that spot and click on it. Now look, if I look at the bottom down there, it tells me that my X and my Y is at 0, 0. If I want to know how big my board is, I can come up to this corner, put my mouse on it. I'm at 2.5 by 1.7 inches. I know how big my board is. So let's do a view. Let's see, fit board. Boom, that's nice. So I got my board inside there. Alright, so I got a kind of a rough layout, but look, what is this? I don't want that footprint. That's crazy. We don't use that part anymore. If you actually saw this part in real life, it looks like a water tower. A little silver metal can with all these leads coming out of the bottom. They still make this part, and they make them as a mil spec or military spec. It has higher specifications. It can take hotter temperatures, colder temperatures, more voltage variations, higher precision. They're very expensive. We're not going to use that. So I'm going to tell it save here, and I'm going to go back to my schematic, and I'm going to look at this and say, hey, this is the wrong footprint. What do I want? I'm going to highlight that part, go to properties, and let's take a look at the properties. I can look at the footprint. Let's drag this down and figure out, how do I want to change it? What's going to be different? I don't want this can. I want a real footprint. So to change the footprint, you say I have footprint highlighted here. There's a lot of different pieces of information here into the properties, but I'm going to highlight footprint and tell it add. I want to add a footprint. Then it has model name. So let's browse. I'm going to browse, let's see, miscellaneous devices. I want a dip footprint, so let's take a look down here. There's a resistor footprints. Here's some surface mount footprints. Right, here's some diodes, all these different diodes. What do I want? Ooh, look at that, DIP 8. That's what I want, the little DIP package. DIP stands for dual inline package. So dual because there's 2 rows and they're inline. I'm going to pick the DIP 8, tell it OK. That's good. Save it. You see the value now is the DIP 8. It's hard to see it because of the way this thing is set up. Here we go, DIP 8. I can save that. So now what happens when I go to design, update PCB, it wants to modify the footprints, execute it, close. Look at that. Now we have a DIP 8 footprint. Makes a lot more sense. Now that cap can go there. Yep, that works. This works. So that's how to change a footprint. I can change that footprint on all my parts. And I think it's a concept that people often miss that's very important. I can come to this resistor if I wanted to and go to properties and see, here's my footprint, that axial. I could tell it add a footprint. And if I wanted to put some crazy footprint in there because that's what my design needed, I could do that. What if I came up here and told it I wanted to dip 16 for that footprint? That resistor is now pointing to a dip 16, and this resistor has pins. We can look at the pins and the properties. There's pin 1 and pin 2. And guess what? On the footprint, a dip 16 has pin 1 to pin 16. If I actually updated my PCB with this, you'll see what it's going to do. Look at this. And where's it putting the connections? Pin 1 and pin 2. So always keep that in mind. The schematic symbol should always be the right schematic symbol. We can point that schematic symbol to any footprint we want. In this case, I pointed it to a dip 16. Not a good idea, right? So I'm going to go back up here to my general, and I'm going to look at my footprints here, and I'm going to tell it, let's go back to the axial. That's what we really want. And tell it, design, update my PCB document, change it back, close. There we go. Now look, is that easy to route that way? I think it's easier to route this way. So there's just a quick example. You can change your footprints anytime you want. Always use the right schematic symbol. Now I look at this board. This is okay, but how would I mount this board in a box? How could I fix this board into a box? I don't have any way to mount it. Let's go back to our schematic symbol here. I can use either one, even the power here. I'm going to go back to components. I'm going to go to the ECE library. Let's see, or maybe my schematic symbols down here. ECE library, schematics. Let's see. No, maybe it was this one. Holes, there we go. I want to put holes. So I'm going to double click these little 3mm holes. I'll place 4 of them. I can save that. And then I'll want to go to Tools and annotate those so they have numbers. There we go. I'll save it. Go to my design, update my design. I'm adding these holes. Alright. Now this is green. Why is it green and this one's not? These are too close to this. So I'm going to grab hole number 1. I'm not going to be too careful about where I place these. We just need to put them up here somewhere. Let's see, let me get this designator out of the way. Notice I can move this designator too. So I'm just going to place some holes. This is a mechanical function that you'll need to mount your parts. I'm not too worried that I'm turning the guys green here. That's not what I wanted. I want to move this guy. I know I'm violating some rules, but that's okay. We'll save that. So now I have holes. I can mount my parts. That's not looking too bad. Let's see, design. I can always come up here to Tools, reset error markers, and get rid of the green if I don't want to see the green. But here's a rough layout. Now I have my input, my output. I can always change things here. If you notice on this guy, on my input, if I go to properties, you'll see that it says input on the comment, but I don't see it on the board. Look at the little I is crossed out. I'm going to uncross the I. Now I can see the text. I can put it right there. That's handy. Maybe I want to add something on here. I'm going to tell it top overlay, place a string. I'm going to hit tab to change the properties. It says buzzer right now. I'm going to say Mike's board. Oh, I know whose board it is. Look at that. I'll stick it right here. Very good. I'll hit save. So I've now labeled my board. I know it's mine. I know this is the input. You know, I could do the same up here and highlight this guy and say show me that says power. Very nice to be able to see these things and know what these things are. Let's do a file, save all, and I'm going to stop this video right here and we'll continue in the next video.